Hi guys, my name is Marmy, and in this video I will be going over a method of ground improvement, stone columns. As the human population continues to expand, soils that we consider poor now have to be looked at instead of getting soil elsewhere for a foundation of a project. The first use of Vibro stone columns can be traced back to the French in the 1830s. However, this method was forgotten for 100 years until it was used by American engineers in California in 1930. The use of these stone columns were for a wastewater treatment plant. The site for the wastewater treatment plant had a history of earthquakes reaching a magnitude of 7 on the Richter scale. This posed a liquefaction problem, and engineers at the time had two options: to use stone columns or pile foundation. The problem with piles is that they lose their skin friction in the event of liquefaction. What exactly is Vibro Stone Column? Vibro Stone Column is a method used to improve properties of soil so that it can be able to withstand the weight of a structure. Cohesive mixed and layered soils generally do not densify easily when subjected to vibration alone. Vibro stone columns can be used for erratic soils, which include cohesive soils. The densification and reinforcement of soils is accomplished by wet top or the bottom feed method during the installation process. With Vibro stone columns of dense crushed stones are designed to increase bearing capacity, reduce settlement, assist with densification, and mitigate the potential for liquefaction, and improve shear resistance. When it comes time to install stone columns, there are two methods that engineers can choose from when installing these. These methods are wet top and dry top method. The wet top method consists of jetting water as shown in figure 1. It is used to remove soft material, stabilize the probe hole, and ensure that the stone backfill reaches the tip of the vibrator. This is the most commonly used and most cost efficient of the deep vibrator methods. However, handling of the spoil generated by the process may make this method more difficult to use on confined sites or in environmentally sensitive areas. The dry bottom feed method is a completely dry operation where the vibrator remains in the ground during the construction process. The vibrator is equipped with a pipe which feeds stones and aggregate to the tip of the vibroflow without being withdrawn from the bore as shown in figure 2. The elimination of flushing water in turn eliminates the generation of spoil, extending the range of the sites that can be treated. Treatment is possible up to a depth of 80 feet and is not inhibited by the presence of groundwater. The goal of Vibro stone column is to reduce shallow foundation settlement, increase bearing capacity, which allows reduction in footing size, mitigate liquefaction potential, provide slope stabilization, permit construction on fills, permit shallow foundation construction, and prevents earthquake-induced lateral spreading. With all things, there is always the probability of things going wrong. The use of stone columns and any other ground improvement techniques requires the user to fully understand why and how such technique will improve the soil that a certain project will be constructed on. Failures of stone columns are the result of inadequate site and in-ground investigation, failures to identify the main risk of or deficiencies in the ground, failure to understand the science and application of stone columns, lack of training in installation of stone columns, failure to consider the rate the load is applied in soft soils, and not consult a stone column specialist. For example, the failure of stone columns beneath an 18-meter diameter liquefied gas sphere constructed in a rigid concrete pedestal foundation in India was the result of not understanding the data collected at the site before the installation of the stone columns during testing. With all the benefits that stone columns have to offer as a solution to improving the strength of a foundation, more research needs to be done to learn more about this soil improvement method. Stone columns are very useful in areas that are prone to earthquakes, reduce settlement, improve rate of consolidation, and prevent liquefaction. As the population of the world continues to grow each year, public transportation will need to grow to meet such demand. As a result, researchers are looking to how soft soil reacts to dynamic loading. Many researchers have studied the effect of dynamic loading on soft soils. Researchers found that with any dynamic loading applied to soft soil, there is a high settlement problem. In order to overcome this problem, it is generally cost-effective to improve the ground compared to importing materials of suitable quality to replace poor soil. This has additional environmental benefits, and it addresses a sustainability problem. As a result, researchers are currently conducting tests on how to improve soft soils under dynamic loading with the use of Vibro stone columns. Currently, the geotechnical engineering program is designed for structures that have soil properties that are considered strong. In order to expose students to real-life challenges, the use of Vibro Stone Columns should be introduced into the program. In conclusion, as the population of the world continues to grow, space that was once deemed poor for any engineering project must now be looked at. The importance of geotechnical engineering is becoming important as new ways are being researched to address this issue. Challenges that poor soil have is having a weak bearing capacity and is prone to settlement, as was stated before. The use of stone columns within these regions can improve the quality of these soils. As technology and methods of construction continue to improve, the use of stone columns as an alternative method for foundation must be researched thoroughly so that it may benefit areas that are prone to liquefaction, settlement, and poor consolidation. I hope you enjoyed this presentation, and thank you for watching.